Welcome, my dear student, in our math program for secondary 3. Dear student, today we are taking a new lesson in mechanic or dynamic. What is the title? The relation between V naught, V, A, and S means the relation between initial velocity, final velocity, acceleration, and distance. أعزائي طلبة وطلبات شهادة الثانوية العامة قسم رياضيات لغات، أهلا بكم. اليوم سنتطرق إلى درس جديد في الديناميكا، وهو العلاقة ما بين السرعة البدائية والسرعة النهائية والعجلة والمسافة. درس مهم جدا جدا، إن شاء الله نتمنى أن نوفق في هذا الدرس بإذن الله. Relation between V naught, V, A, and S. Dear student, look at what you mean of uniform variable. Means acceleration equal constant. Dear student, look at the opposite graph represent the relation between V, V naught, and time t. Look at V minus V naught over t equals 0. Therefore, V equals V naught plus AT. Look at the distance, or S means sum of area of a triangle. S equals V naught T plus half, bracket contains V minus V naught T. Dear student, the first equation is S equals V naught T plus half Vt, but in this case we represent V by V minus V naught times T. Remember, dear student, the second equation is clear that the relation between distance and V naught and the acceleration A. S equals V naught T plus half AT square. Remember, dear student, this rule, when we find the distance and the given is V naught, A, and T, the relation between S, V naught, T is S equals V naught T plus half AT square. What is the meaning of V naught? Is initial velocity, A acceleration, T is time t, S is the distance when particle moves from place or from A to B. Find the distance by using V naught and time t. With substitution about acceleration A, we find the distance when particle moves from place A to other B. Look at square 1 and square 1 substitution in equation 2. We find the relation between V and V naught is V square equals V naught square plus 2AS. This rule is very important. Why? Because the relation between maximum velocity and initial velocity by using acceleration A and distance S. Remember, dear student, this equation or this rule very important. Why? Because this relation between two velocity. We have initial velocity and maximum velocity and acceleration A. After that, we given that S is the distance between, or the distance when a cover or particle covers from A to B is S distance, represented by S distance. This rule very important to find the final velocity. We give V naught, A, and S. And if we know relation between maximum velocity and initial velocity, we use this rule. Or when we find final velocity or maximum height, when particle reach to maximum height means maximum velocity is equals 0. Maximum height v final velocity equals 0 by using this rule to find the distance covers from A to B or from place to the other place. Example. When particle moves with acceleration 2 meter per second square, v naught 5 meter per second, find v after t equal 7 seconds. Look at the solution. This rule is using to find the velocity v equal v naught plus at by substitution. About v naught is 5 and acceleration is a equals 2 after t equals 7. Substitution is answer 19 meter per second. Dear student, when particle moves with initial velocity 5 with acceleration 2, find the final velocity after t equal 7. v naught, v equals v naught plus at. This rule by substitution about v naught equal 5, acceleration a equals 2, after t equals 7, we find the final velocity 19 meter per second. Find the distance after 3 seconds. This rule, when we find the distance after 3 seconds, we use the second rule as equal v naught t plus half a t square. Remember, dear student, the given is v naught equal 5, t equal 3, and by using acceleration is a, we use this rule to find the distance after 3 seconds. After 3 seconds, distance equals by using or by substitution about v naught equals 5, v naught equals 5, t equals 3, acceleration is 2, then 5 times 3 plus half times 2 times 9 is equal 15 plus 9, 24 meter. Remember, dear student, particle when t equal 3, it covers 24 meter. When particle moves with initial velocity 5 and acceleration 2 with acceleration 2 after 3 seconds times 3 seconds, the particle covers distance. This distance is 24 meter. Remember, S equal v naught t plus half a t square. This rule to find the distance when the particle covers distance with initial velocity and acceleration after t second. Look at, dear student, another example. Find v. What is the v? Final velocity. When particle moves with acceleration a equals 3 meter per second square and v naught equal 4 meter per second. Remember, dear student, what is the required? Final velocity. What is the given? Excellent student. v naught equal 4 meter per second and acceleration a equal 3 meter. After that, when covers 10 meter, when particle covers 10 meter and moves with 4 meter per second, with acceleration 3 meter per second squared, find final velocity v. What is the rule? Excellent student. Third rule, v squared equals v naught squared plus 2as. Look at the solution. Look at, dear student, v squared equal v naught squared plus 2as. Dear student, in this case, dear student, we use the third rule. What is the third rule? V squared equal v naught squared plus 2as. Why? Because the required is final velocity. The given v naught and acceleration and the distance which particle cover it. By substitution, v naught squared equals 16 plus 2 times acceleration 3, distance 10. Answer is 76. V squared equal 76, then velocity is v, positive or negative, square root 76 meter per second. Look at, dear student, another example. Particle moves from A to B at t equal 3. The first in statement, second t equal 7, A point 5.2, B point 9, 10, or vector A equal 5.2, vector B 9, 10. Find number 1. VA in this case equals R2 minus R1, or difference between two positions over distance between 2 times, or 2 instead. The first, look at R2B, the point B, 9, 10. This position of the particle R2 means point B, 9, 10. R2 means point A or vector A. T2 equals 7, T1 equals what? 3. By subtraction, 9, the ordered pair, 9, 10, minus 5, 2. Answer is 4, 8 over 4. This is 4 over 4 equals 1, 8 over 4 equals 2, 1 in direction I, 2 in direction G. Then number 2, VA, what is the norm? We find 1 squared plus 2 squared under square root equals square root 5. This velocity after when the particle moves from A to B. Look at another example. Find BA in the previous example in same direction. VBA, what you mean? Equals VB minus VA. What is the VB by substitution? Equal 30 unit velocity. But VBA in the opposite direction equals the same rule, but VBA equals VB and VA equal 7 by subtraction unit, please. Look at another example. Dear student, the opposite figure clears that the relation between the distance and time. Look at when particle moves at time equals 1, it reaches 4 meter. Look at, dear student, from the curve of the distance time, find number 1, V naught at 0, 2, 3. V equal difference between two distant with two covers over difference between two time. Look at, dear student, as a first by substitution, then -2 when, look at, when the particle covers a 2, distance is -2. When the cover, look at -2 minus 0, -2 minus 0, this is, yes, distant. 3 minus 0, this time, T2 minus T1. T1 equals 0, T2 equals 3. S2 -2, S1 equals 0. By substitution, answer is -2 over 3 unit vector. V equal 2/3 meter per second. Number 2, when from 0 to 1, V naught V S2 minus S1 over T2 minus T1 equal 4 over 1 equals 4 accelerated velocity. V from 0, acceleration from 0 to half, 2 over half equals what? Equal 4. V initial in state in this instant, 2 over 1 over 2 equals also 4. Now we are translated to another example. Look at stone projected upward. Look at, dear student, when stone projected upward, find the distance is equation of the distance represented by S equal 49t minus 49t squared. Distance is positive, S equals 0. Distance velocity equal ds by dt by differentiation respect to time t. Remember, dear student, when S equal 49t minus 49t squared, and we find the velocity v, we derivative the distance respect to time t. V equal ds over dt by derivative respect to time t. V equals 49 minus 9.8 t. Number 3, d is negative 9.8, decelerated or retardation. Va smaller than 0, this is decelerated or retardation. Retardation means Va smaller than 0 or negative, but when Va more than 0 is accelerated, but in this case Va smaller than 0 is retardation. Maximum distance at V equals 0 by substitution, distance V equals 0, remember V equal ds over dt. V equals 49 minus 9.8 t equals 0 by using left hand side and right hand side, then t equals what? T equals 0. Maximum S means find S at 5. By substitution, S equal 5, answer is 122.5 meter. Number 5, when S is 78.4, by substitution to find the value of t, t squared minus 10 plus 16 equal minus 16t equal plus 16 equals 0, then t equal 2, t equals 8. After that, find the velocity at t equals at 2 by substitution in velocity by using t equal to, then v equals 29.4 meter per second. v8 negative by substitution about 8 equals negative 29 meter per second in the opposite direction. When stone return back, s equals 0, t equals 0, or t equals 10, v naught equals 49. Look at, dear student, the opposite figure represent when t equal 2, when t equal 8, then velocity is equal 0. When t equals 0, the particle is 49. v equals 0 at t equals 5. Maximum distance, we find the area of triangle of AOB by using area of triangle of OAB to find maximum or a maximum distance. Maximum distance means area of triangle of AOB. Area of triangle half base times height. What is the base of triangle AOB? Is 6. What is the height? 49. Then by using half base times height, 5 times 49 equals 122.5. Remember, the area of triangle of AOB mean maximum distance. Then OB equals 5, OA equals 49, area of triangle is 122.5 is mean maximum height when particle moves it. When we find S from 0 to 10 by using same half base times height equals from 0 to 10, we subtract the area of triangle, half 5 times 9 minus subtract area of triangle half equal 0. Look at the opposite figure, dear student, represent the distance and the time. When v equals 0, t equals 1, or t equal s. T equals 7, look at 7, 8, 9. And so when v instant equals 0, at t equal 6. Number 3, when v more than 0, look at t equals 0. T equal belongs from 0 to 1, from 0 to 1, union 5 to 6 at t equals 6. When v smaller than 0 at t equals 0, t belongs from 1 to 5, union 6 to 7. When a equals 0, t belongs open interval to 3. Look at, dear student, the opposite figure, very important. Clear that the derivative and integration. When we find acceleration, a dv over dt by derivative. Velocity respect to the time t. When we find v, we use derivative of s respect to the time t. Look at v, we have relation between a, v, and s. S the distance when particle cover it. When we find the velocity, we use derivative dv ds over dt. When we find acceleration a, we use the derivative of the velocity respect to the time t. Then average velocity vector equals SF minus ST over T2 minus T1. Instant velocity V equal the derivative, the distance respect to the time t, V ds over dt. Acceleration A dv by dt. Remember this relation between acceleration and velocity. When we find acceleration, we derivative velocity respect to the time t, but velocity is derivative of distance respect to the time t. When Va more than 0 is called accelerated. Accelerated motion when Va more than 0, but when Va smaller than 0 is decelerated or retardation motion. Dear student, we have two motion, accelerated and decelerated. Accelerated motion when product of velocity, magnitude of velocity and magnitude of acceleration more than 0 or equal positive. Decelerated means Va smaller than 0. V equal Fs, what you mean is function V function of S and S gt function of t. Acceleration dv by ds. Remember, dear student, acceleration dv by ds times ds over dt. Remember, this rule is very important. We know that acceleration is derivative velocity respect to the time t, but in this equation we put A is equal dv over ds times ds over dt. What you mean? A equals v dv over ds. Why? Because v means ds over dt. By substitution about ds over dt by using v, then acceleration A equals v dv by ds. Then A acceleration equals v times d2s over dt square. Why? Because dv by ds equals second derivative of distance respect to time by substitution about dv by ds is d2s over dt square. Then the second relation between acceleration and velocity is A equal v times d2s over d2 dt square. But the first is v dv by ds. When you use the first, we give dv by ds and velocity. But when you use the second, we find ds by dt and derivative of ds over d2 dt. After that, multiply v to calculate the acceleration A. Dear student, by the end of this lesson, we know that the relation between the distance, velocity, and time and acceleration. We know that acceleration A is derivative of velocity respect to the time, but velocity is derivative of as respect to the time. This rule is very important lesson. Dear student, I am very happy to spend such time with you. Goodbye.